We'll start with chapter 1, HCIA network track training. So first of all, I would like to congratulate all the students who are selected for the next round of HCIA. Okay, so we'll start with the first chapter, data communication network basics. Okay, so here we'll first focus upon these are the different Huawei device icons. Okay, so router is represented like this. So it's like a representation. Okay, how do each device looks like? Okay, this is firewall, access point, like that. Okay, just go through that one. So we'll start with the different types of communication networks, different types of networks, topologies, what is network engineering, what is network engineer, like that. Okay, so first one, see, the diagrams are important. Okay, so here the network communication means what? Information transfer or exchange between people and things, and between things through a medium. See here, the diagram shows the same. See, first one, files are transferred between two computers. So one computer to other computer, they are transferring file. That's a network communication. See, second one, the computer is downloading file from the server. That also is a part of network communication. Then see, different computers are being connected through a router. Okay, so files are transferred from multiple computers through a router. See here, there is only two computers are directly connected and they are transferring file. Here one computer and server are connected, they are transferring file or downloading file. But here all the computers, more computers are connected in a network using a router, and they are sharing the file using the router. Okay, so that's what written over here, so no need to do it again. Now how the information transfer happens, what is the information transfer process? Okay, so usually it is similar to the real object transfer. See, I have some object, I want to transfer that to other person in another place. What I will do, I will have the object in my hand, then will pack the object, give it to the distribution center. They will transfer it or send through maybe airlines or transport bus or some lorry, okay, or whatever truck or something. Then again went to the distribution center of other place, okay, the office in the other location. Then they will get that packet. From that they will take the object and that real device which you want to send. Okay, same here, the data is the one which you are going to send. We call it as payload. Okay, that data will be converted to packet. We add header and trailer information. Okay, head and tail, or we call this header and trailer. Okay, head at the beginning of the data, tail at the end. So this will become a packet. Now the data payload become packet. It will be given to the router. Okay, what the router will do? Router will forward this packet through the internet to another router in another network. Okay, what they will do? They will get the packet. From that they will separate the data and give it to computer. This is happening in information process transfer, same like happens in object transfer, real object transfer. Okay, now these terms, what is that? So actual data we are using, conveying, or information we are going to send is data payload. It will be converted to packet when we add the head and tail, or header and trailer. Okay, header and tail will become packet. Header means so information added before the data payload. Maybe like the address information, source address, destination address. Okay. Tail information added after the data payload. That may be error correction, error detection data, synchronization data, all those things. Okay. Encapsulation means how do we, the process of adding a header and a tail to the data payload to form a packet. It is called as encapsulation. So here when I add, this is the data payload. Okay, when I add a header and a tail, this becomes packet. Now adding those header and the tail to the data and to make it a packet is called as encapsulation. Okay, when it reaches the receiver side, we'll remove that header and tail part, just the data we need or the payload we need, that is decapsulation. Gateway means, see, every network will have a gateway. It will be a router or any other network device. Okay, so that device is the one which connects the end device to the outside network or internet, that is gateway router. So what they will do, they will do the protocol conversion. Okay, so data will be moving from one network to another network. Okay, maybe Wi-Fi to Wi-Fi, maybe from LAN to WAN. So those times, no, we have to convert the protocols. Okay, so different conversions, protocol conversions, SDLC, whatever conversions are there, all done by this gateway. Sometimes we have to convert the data from media, one media to another media. That also done by gateway. Then route selection. So there will be different routes. Okay, we have to choose the best route. There will be different paths to reach the destination. Choose the best one. Okay, that also done by gateway. Then exchange the data. Okay, a router. So usually the router will be acting as a gateway in every network. So they will be having a routing table. From that, we will choose the best route to forward the packets. Okay, terminal device or end device is actually the sender or receiver. Okay, here also this is the terminal device, either sender or receiver. Okay, this is what given in this particular table. Okay, the same thing they are repeating, so no need to again repeat. Now data communication network. So this is the network. Okay, so we have different layers. Okay, this is the internet part. Okay, the router or the internet part. Okay, so here we have core layer. Core layer means the device where we have routing is done. Okay, so there we have routers, firewall, everything is core layer. Then we have distribution layer. Distribution layer means it is given below core layer. They also have router part and switch part and all. Okay, last one is access layer. This is a layer where all the end devices are connected. So core layer will do routing. Distribution layer is between core layer and access layer. Access layer is a layer where we have switches which will be connected to end devices where the computers are there. Okay, so communication network will have router, switches, firewall, access control, access point, PC, network printer, server, everything. Okay, why we need this? To implement data communication. You know that router means connect two different networks. They will be connected to internet, they will be connected to LAN also. Switches are the devices which are connected to end devices. They will forward the frames. Okay, then firewall, is the one device which protects the intranet from internet. Okay, so they have some access policy, so there will be packet filter firewall. So this firewall will filter the packets, incoming packets coming towards the LAN, also filter the packets going outside the internet. Okay, so they are firewalls. Then access controllers, they are the devices which are used to control the which one, access points or the wireless devices. Okay, access points are actually used for connecting the wireless clients to the network. We have a mobile phone. Okay, you want to connect that, or laptop to connect to the wireless network. Okay, so we have access points. So access points connect the wireless clients to your network. Okay, then PC, end devices, network printers. So the printers are being connected to network, so the devices can share the printer by using network. Okay, servers. So every network needs server. No, HTTP server for web access, email server for email communication, like that. All the servers, all these coming in a single unit is called as data communication network. Okay, then see here, switch is the closest device to end device. Okay, all these computers are directly connected to switch. So in a switch, usually when you are using Cisco switches, we'll have 2960 24 port switches. So we can connect 24 computers or 24 end devices to that switch. Okay, and it is working in layer 2. Okay, it understands only frames. So layer 2 means data link layer. They understand only frames, and they will make only frames, and they understand only MAC address. Okay, so here, what are the things which can do? It is closer to the end user. Okay, it is used to connect the terminals to campus network, and they are also called as Ethernet switches because layer 2 we have data link layer. Okay, it is data link layer in TCP/IP model, and they will perform the functions like data frame switching. So a frame means a PDU, a protocol data unit which contains data plus MAC address. Whenever you have a data, when you add MAC address for that, it will become free. So the computers understand. No, computers will be, the switches will forward frame from one computer to other computer. Okay, that is data from switching. Then to access the end user devices, switches can be used. Okay, then basic security functions. Okay, there are some basic security functions like port security is added in switches. Okay, that is done in switches. Then layer 2 link redundancy. So the switches can be connected. Okay, we can have redundancy. So we one switch to another switch, we can have many cables. Okay, so redundancy means one is down, we can use another one. So here we have which one, ether channel. We have ether channel concept. Okay, that is done by using switches. Okay, and we have broadcast domain. So here there will be broadcasting happen between the devices in a switch. Okay, switch will broadcast all the frame, whatever frame it receives, it will broadcast every other end device or every other switches, that is switch. Okay, then main thing about router is router will connect two different networks. Okay, and it is a layer 3 device, network device. it creates packets. Okay, how do we create packet? The data added with IP address, source and destination IP address, it will become a packet. Okay, so switch means it make only frame. So there they understand only MAC address, but here they understand IP address. So packet means data added with IP address is packet. So router will forward packets. Okay, and what they will do, they will implement C communication between different networks, and this is a part of network layer, any layer 3 device. Okay, switch is layer 2. Isolate broadcast domain means it will not forward broadcast from one network to another. So see, here we have one network, we have broadcast, here we have another network, we have another broadcast. Okay, so router will isolate, it will not forward broadcast from one network to another network, it will stop broadcasting. So maybe will ask somebody will ask you what is the device which will not forward broadcast or it will isolate broadcast domain. It is router. Okay, every router has a routing table. There we can have what are the different routes to reach network. Okay, and they will have routing protocols to forward data from one network to another. Okay, so based on the routing table, will that router forwards the data from one network to another. Okay, there will be static route, dynamic route, that depends, it will be coming later. Okay, then so whichever routes are, which one shortest, we will choose that route. Okay, and forward that router will choose the shortest route and forward the packet. So it depends upon direct route or static route or dynamic route, that we'll discuss later. So it will implement WAN also, a wide area network connecting two different LANs. We can have router, so that will implement WAN also. Okay, and it also performs NAT. NAT means network address translation. So that public IP to private IP or private to public IP, that translation is done by NAT. So example, you have a computer here, its IP address is private. Okay, when it is being used in the public network like internet now, this IP will be converted to public IP. Who will give that public IP? NAT. So NAT is implemented in router. So router will have NAT, network address translation. It will convert private IP address used in private network to public IP address done by NAT. Okay, whatever I told is mentioned here. Okay, firewall is a device which is between intranet and internet. So intranet means your LAN. It is trusted zone. This one is untrusted zone. Okay. So here we implement the firewall. We will implement security policy. Okay. So that the unwanted packets will not reach here. Okay. It will filter the packets, filter the IP address for all going to communicate to my LAN. So firewall will filter those packets. Okay, they will perform user identity authentication. He will perform identify or authenticate the username with username and password who are going to enter the network. Okay, VPN service also there. They will implement the VPN, no, virtual private network and encryption, so that you can access the devices, but we need to have a private connection. Okay, and they have implemented remote access. We can remotely access the device, but through security. Okay, security protocol, and we have NAT also. So firewall, it is between two different network. One is untrusted. We cannot trust those people from internet. And trusted people means my own network. Okay, it between internet and internet. Intranet means this one. Internet means outside. Okay, they control communication between these untrusted and trusted zone. Okay, by implementing security policy, what they will do, they will have like a packet filtering firewall. So they will filter the packets coming in and coming out. Okay, going out. So why we are doing this? To prevent unauthorized access. So nobody from outside cannot access the resources in my LAN without my permission. Okay. Then wireless devices. So we have heard about access point. Access points are used to connect the end devices to the wired network. Okay. Through wireless network, we can the wire laptop can access the wired resources in my network. Okay. There are two things: fat access point, fit access point, and access three things. Okay. Actually, fat access point, fit access point, access control. Okay, fat access point means, see, this is connected in a home network. Okay, it is independent. We can configure. See, the whatever access point we have in our home, it is fat access point. Okay, you can manage it, you can configure it, you can change the IP address, you can change the network name, everything you can do. This is what called as fat access point, and this is low cost. Okay, fit access point means it is used in some companies. Okay, you cannot easily configure it, it will be controlled by a access controller. Okay, from here only we can manage these access points. Okay, so fat means It is in home, you can manage. There is no centralized person, you can manage yourself. Okay, but here fit access point means it is used in companies and you cannot control those things. It is being controlled by access controller. There only we can control or configure this access point. This is fit access points. Okay, that's what fat and fit. Okay, that is done. Then different types of network, LAN, WAN, MAN. LAN means local area network. Okay, it's in a few square kilometers. They are used to connect end devices which are close to each other, like family or within buildings or campus. Okay, they use Ethernet and Wi-Fi. Ethernet means connecting the computers in a wired format. Wi-Fi means wireless connection. Okay, between the end device in a few kilometers. Okay, MAN means metropolitan area network. It's for a particular metropolitan area or a city. Okay, connect host database lands at different locations, same city. Okay, so technologies are Ethernet 10 gigabits per second or 100 gigabits per second and WiMAX for Wi-Fi, wireless. Okay, wireless max. WAN means wide area network, several kilometers, not just cities, like spread across different states. Okay, several kilometers. Okay, thousands of kilometers. Connect lands or mans. See, across cities or countries or states. Okay, so we use the telecom operators help. Okay, like Omantel, Urdu. Okay, then technology use SDLC and PPP, point-to-point protocol or high-level data link protocol. Okay, HDLC. This is the technology they use. Maybe they'll ask you which network is used in for connecting devices in a city, man. Okay, which network is used for connecting, say, countries or another one city, another city, like that. Okay, so we can all make it WAN. Okay, LAN means connecting computers in a small room or a little like a square kilometers. Okay, buildings, campus, like that. Okay, then we have, see, it's already given here. Okay, the diagrams. Then what is network topology? Topology means a layout or picture showing how the medias are used to connect the different devices. Okay, so we have twisted pair optical fiber cables and we'll connect computers, routers, switches. Okay, this is what topology. I'm connecting all end devices, routers, then switches, firewall, everything by cable or wireless. Okay, this is called as topology. When you go to a network, any network engineer, they will show you the topology, how the devices are connected. Okay, so here there are different types of topologies: star, bus, ring, tree, full mesh, partial mesh, combined. Okay. Star means, see, there will be a centralized node or centralized device. Okay, all are connected to the centralized device. This is the one which controls everyone. If this is down, all the communication will be gone. Mention here. Okay. All are connected through a central node. Okay. Then advantage is you can easily add the new devices. Okay, just connect a new device to centralized node, put a cable and connect a new device here. Okay, the disadvantage is fault on central node affect all communicate. Okay, if anything happens to centralized node, that particular device, everything will be disconnected. Okay, that communication will be failed. Now best means, no, everybody is connected to a common line. See, there will be a single line, all are connected to, all end device connected to single line. Okay, see here, all are connected through a single bus or a coaxial cable example. Okay, advantages: easily you can install, and cable resource also saved. Okay, no need to have separate cable, only one cable, then connect all device. Okay, then disadvantages: bus fault affects entire communication. Okay, if any problem with the bus happens, all the communication will be lost. Okay, ring, third one is ring, all are connected in a circle manner. Okay, all are connected in a ring format. Okay, and the advantage again, cable resource, no need of so many cables. Okay, one cable will control device. The problem is adding new devices. Okay, so when you are going to add a new device, you have to interrupt the ring because it's communication. Let's stop the ring, then add new device, then again you can start the ring. Okay, then we have tree topology. It's a hierarchical structure, a star structure. See, there will be a top node, then again another one node, then another node, like that. Okay, so hierarchy is there. This is the topmost, then again second one, then third one. Okay, like this. Okay, all end devices are connected in this manner. Okay, so here the advantage is multiple star networks can be combined. So here we can easily expand the network, add another star network. So all these star networks are connected. Okay, the disadvantage is a fault on a node at high level is more severe. Okay, whatever happens, if this node is gone means they cannot communicate. If this node is gone means These two cannot communicate. This node in board means all those colors. Okay, all those nodes cannot communicate. This is problem is star topology. Sorry, tree topology. Okay. Full mesh means see all the nodes are connected to each other. So much redundancy. Every cable has see this cable. If you want to reach here, this which one node can easily go here. Either this way, many way they can reach. But problem redundancy is there. Okay. Problem is more cables we need. See this particular node has one, two, three, four cables. Okay, that's what mesh full mesh topology. All nodes are interconnected through cable. Advantage is high reliability and communication. Okay, so there are so much cables there. Okay, one gone also you can use another one. Problem is every node requires more number of ports and cables. Okay, so costly. Partial mesh means only few or important nodes are interconnected. The cost is lower than the full mesh. Disadvantage is reliability is lower than that of full mesh. So here partial. Not every device is connected. There no, they are being connected, but the number of connections are less and the cables also less. But the problem is reliability is less compared to this one. Combined network means all together we make a combined network topology. Okay. This is what about topology. Now, what is network engineering and network engineer? Okay. Network engineering means planning. So we want to plan and make a feasible solution, best solution for the network requirements. Okay. So what are the network standards we want to create? What are the technologies we want to use? Everything comes under network engineering. Okay. So he has to choose the where here we will choose the hardware devices we require, software requires we require, what are the technologies we need. Okay, everything which means the user all comes under network engineering. Okay. So here who will do this thing? Okay, so see here network engineering will do, they will cover like network planning, plan the network, how many nodes we need, how many servers we need, how many cables we need, design the network by using, say we can use a packet tracer simulation like that. Here we have ENSP tool for simulating the network. We can design that, implement the design. Okay, then commissioning and troubleshooting. Okay, so here who will do this? Network engineer. See, he should have three important things: professional knowledge about network, basic qualification, then professional skill. Okay, professional knowledge means the industry knowledge. Okay, you should know have an idea about the industry, the network industry. Okay, that the company. Then engineering knowledge, you should know some basic engineering knowledge. Okay, how many nodes we need, what are the technologies we can use, how many what are the protocols we use. Okay, like that. Product knowledge. Okay, you should have some knowledge about the particular product. Then technical knowledge. Okay, so we should have like a HCIA qualification or CCNA qualification like that, no? So that we can get some idea. Okay, then basic qualification, no? Business ethics. So you should know some how to handle the customers. Okay, value. You should have some values. Then service awareness. How do we serve the customers? Information collection. Then learning. We need to be updated himself every time. Okay. Then professional skill means you should be having that skills like team collaboration. Okay, he has to work with different team members. Okay, he should have some business management. Okay, then he should have presentation capability whenever we are being asked to uh, present a particular idea to the clients. No, you should have some presentation capacity or the idea. You should have problem solving capacity. Okay, so you should know whenever some problem happens in network, know how to solve it. Okay, how to troubleshoot it, how to solve it, everything you should know. Then communication capability, you should know how to communicate this idea to the other people or team members. No? That all should be there in professional skills. So these three things together make a network engineer. Okay, it's mentioned here. Should have professional skill, you should have technology skill, you should have implementation skill, everything mentioned here. Okay, these things are coming under chapter 1. Then remaining, what are the Huawei certifications available? Okay, we should go for different certifications to get the uh, become the Huawei certificate engineer. Okay, there are so many exams, HCIA, routing, route switching, cloud exams, so many exams are there. Okay, go for. So there are the Huawei certification, which one categories? Okay, start with HCIA associate, then professional, then ICT expert. Okay, information communication technology expert. Okay, this is the certification, which one path. Okay, you will go like this. Okay, so HCIA, then we go for HCIP, then HCIE. Okay, this is what coming under chapter 1. Okay, hope you understood. And we have this courses here. Okay, HCIP, Datacom, like many courses. Okay, then see one question they asked is which type of network topology is highest reliability. Reliability means many connections will be there. If even if one connection gone also, we can use the other one. So here star, ring, full mesh, and tree. Answer is full mesh because full mesh means all the nodes are connected to any every other node. So more cables. If one cable gone also, we can reach the other cable. Okay, one node gone also, we can reach the other node like that. That's why it is C is the answer. Okay, this is coming under chapter one. Hope you understood.